Okay, everyone. So this is 2019 AMC 8, number 24. So we have a triangle, and then we are given some ratios. AD to DC is 1 to 2. So let's call this is 1K, and that means this is 2K. And E is the midpoint. So this guy is the same as this one. And we have the F is the intersection of AF and BC. Okay, that's the intersection. And the area of ABC is given based on that we are looking for the EBF. Okay, so we need to find the area of this region. Okay, so whenever you see some sort of ratios, it's good to think about hunting for similar triangles, right? Because the similarity is basically just proportional triangles. So which is why I'm gonna kind of remind you some common types of the figures that you will need to look for some similarity. So whenever you have such a triangle where you have two lines like this are parallel, then this guy right here, so if I label those, okay, so ABC and ADE are going to be parallel. The reason why they are going to be parallel, the angle right here and the angle right here will be corresponding angles. They are going to be congruent, and this angle and this angle will be corresponding. They are congruent as well. So in ABC and ADE, right now I have already two pairs of angles. This is same as this one. This is same as this one. The angle A is actually same as angle A. If you split ABC and ADE, they will have three same angles. So if you have two same angles, that is enough to say they are similar. So that means ABC and ADE are similar. Okay, so for that reason, if you can find some parallel lines, it's good to have some similar triangles because the ratios will help us. So for that reason, I'm going to take this point D. I'm going to make a parallel line that is going to be parallel to AF. So why I'm taking that point? The reason I'm taking this point, when I do this, you know, this is going to be a triangle and AFC will be another triangle. They will be similar since that will be parallel to this guy. That's one thing. And the second reason is, you know, this guy, this triangle, which is what we are looking, is also similar to this bigger one because this is parallel to this one as well. So which is why it's good to have maybe DH as a parallel line. Okay, so now after we got this one, so let me kind of make a few more comments. So if these guys are equal, for example, that means BC is the midpoint. So the ratio of this to this is going to be 1/2. Okay, and if you have similar figures, okay, I'm going to call that is like, let's say this is actually, yeah, this is going to be AC over AE. So that's 1/2. This is called the proportion, the ratio of the similarity. Okay, ratio of similarity. So whenever you have two figures are similar, the square of that proportion is actually ratios of their areas. So in this case, you can say the area of the ABC divided by area of the ADE is actually the square of this proportion. So in this case, it's just 1 to 2, which means that will be 1 to 4. So I will say AB over AD, that's the ratio of those two corresponding sides. And if you square this one, that will be ratios of their areas. In this case, since this ratio is 1 to 2, that means you will get 1 to 4. If I call this area 1A, okay, area, the area of the AD will be 4A, which makes this region to be 3A, okay? So just keep this in mind because we are going to use this one. You know, we are told this region, I mean, this is midpoint of BD, right? So if I use the same reasoning, you know, this BEF and BDH are similar, and the ratios BE to BD is 1 to 2. So if I say this region is 1A, that will be 3A, okay? So that is something we need to keep in mind, okay? And now I'm going to ask you to think about the triangle BDH H. Okay, so think about this triangle only for now. And this triangle and this triangle. So on the left one, we have the area of the BDH, which is 4A, and the base is actually, we don't know yet, right? But let's actually include some information as well. Since this is midpoint, that F is also going to be midpoint. This is parallel. So then if I say this is A, then this is A. And since we know DH is also parallel to F, like AF, and then we had the 1K to 2K ratio. That means if this is 1A, so that would be 2A. So now we are good with this. So the area of the BDH, this guy, is 4A in total, right? And the base of that triangle is 2A, but we have another triangle right here that has also base of 2A. And if you see that the point D is there, the same vertex of this left triangle and this right triangle. So if this triangle has 4A as area, that means this region will be also 4A. Okay, so now we are getting almost everything in terms of what we are looking for. So we had 4A, 3A, and 1A for their areas. Okay, and now we have one more step. So if you are really now looking at the triangle ABD, like this triangle, okay, this is a triangle, and the BDC, if you look at this triangle, so they share a vertex at B, and then their basis is K to 2K ratio. So that's 1 to 2. And I do know this region was 8A in total. That means ABD, the area of the ABD, should be half of that 8, which is 4A. So I hope that makes sense because, you know, this is my vertex. And if I like drop the altitude, like from B to AC somewhere, so I have no idea where it's going to be landing, but like the height will be the same for ABD and BDC. And then the base ratio is 1 to 2K, which is why the area of the ratios will be 1 to 2 as well, because the height is the same. So the base is 1 to 2 when you write base times height over 2. Or so your base is 1, base is 2 times of the other one. So the area will be the same thing. Okay. So that's why we can say ABD is 4A. And this is going to be 8A in total. ABC, okay, is equal to 12A. And then we are given this is 360. And if you divide by 12, so you will get actually 30, which is actually what we were looking for. So that is my answer. So this is one way. Okay, so I'm going to do this question slightly differently as well. Okay, so, you know, at the beginning, I said I can make a triangle like this one to make some similar triangles. That was one of the common ones. But another one that we have actually, we can actually make a parallel line from D to AF that will be parallel to BC. And because that's really common type as well. So these guys, let's say parallel. And in this case, you know, the angle right here and the angle right here will be equal, and same this guy and this guy will be same. Okay, and since we do know this is the same as this one that was given, and then this was 1 to 2K, and this triangle right here and this triangle right here will be similar because you already have these two same as these two, and then this angle and this angle are actually also same because they are corresponding angles. Okay, so I'm gonna actually let me shade those. So this angle and this angle are also equal. They are corresponding. I mean, they are vertical angles. So again, these two triangle are similar. And if you look at the side, you know, this side is opposite this angle, the same side opposite this one. The proportion is actually 1 to 1 because this guy has the same distance as this one. So the proportion is 1 to 1. So which makes, like, if I say this is X, then this would be X. Okay, that is something we have. And we already know, you know, this is K to 2K, and then this is parallel. So you can say that if I say this is something, then this piece should be twice as big. So let's say this is gonna be y, okay, h, then hf will be twice as big because you have 1k to 2k. And I do know this piece and this piece are equal because this was just a midpoint, and that would be the same. So then hf is 2y, and then this piece will be just 1y, and this piece will be just 1y, okay? So now I'll use this similar reasoning that I did have in the previous problem. So we have now, this is x, right? And we do have, like, let's actually call this is still A. That's what we are looking for. And then if you take a look at this triangle, BEF, okay, the base is 1y. If you look at the BEA, the base is 2y, which is 2 times as big, and that would be 2a. Again, if you are not sure what I did right here, so it's basically, maybe I should have done this at the beginning. So whenever you have two triangles, let's say you have something like this. Let's say you have three different triangles. Okay, A, B, C, D, and E. So if this is, let's say, K, 2K, 3K, the area of this triangle, area of this triangle will be proportional to these guys. The reason why this is the case, because if you drop A altitude, from A to BE, that height will be same for all three triangles, okay? And that would be 1A, that would be 2A, that will be 3A, just because of those ratios. If I change these numbers will be changed accordingly, okay? So which is why we have 2y to 1y ratio with the same vertex. So that's why 1 to 2a. Okay, that's something. But if you look at this triangle, okay, this triangle ABE and AED, they have the same base and they have the vertex A, which means ABE and AED has the same area, which is 2A. And that means AED, so let me write down, AED, okay, is gonna have 2A as well. Since this is right in the middle, so that area will be split into these pieces. So that should be 1A and that should be 1A. Another way to get this region was, this region and this region was exactly the same. They are not just similar, they are congruent because the proportion was 1 to 1. So instead of doing this this way, you could have done this from A to A immediately as anyway. Okay, so now we have that as well. But we have these, but I don't know this piece, right? Maybe I should do something additional to get that. So what I'm gonna do, I'm gonna connect E to C. And how I decide that? I decide because I do know this region, which is 1K, and then I do know this is 2K. If I have a triangle like this, I could have this region easily because that's the ratio 1 to 2. And this region was 2A. That means this region will be twice as big, which is 4A. Okay. And that is something also we know. And we already know FC from the previous problem, but let's ignore that. I'm going to use something else right now. So if you take AEC, like this triangle, and ECF, so they share this as vertex, common vertex. The area of this region is 6A, and the base is 2y, and the base of this is 1y, which means the half of this region should be this region, which is gonna be 3A. Okay, so we are done with everything, I guess, okay? So now we have 3, 4, 7, like 8, 9, 10, 12. So we have the same thing, right? 12A is 360, and A has to be 30. And that is your another approach. So I use the similarity. That's one thing that I use. And the second thing I use is comparing the areas in terms of their basis. Okay, so that is another way that I use in these two different solutions. Okay, so I hope that makes sense and you're fine with that. Okay, I'll see you next time.